Hi, this is a video on multiplying fractions. I would recommend learning this and watching this before you do adding fractions. So I am going to share my screen. Let's see, and you will see my notes come up in just a second. You can have a copy of these notes in front of you if you'd like, or you can write your own. It's up to you. See, yay, there it is. Okay, so these are my notes. Yours should look like this. I'm going to zoom in a little bit here. That's better. Okay, so this is on page, well, it's a little bit frozen. There we go, page 8 of the notes if you have a copy. Multiplying fractions is really easy. It's not much involved. You literally just multiply straight across and then simplify. That's all. That's what reduce means. It means simplify. So let's just hop right in. It's very straightforward. We're going to multiply straight across on the top and the bottom. That's all. So 3 times 1 and 8 times 4. Then at this point you want to see if it reduces, and 3 and 32 have no multiples in common, no factors in common, so that is it. Isn't that so simple? Let's look at the next one. Same thing, straight across on the top and the bottom, numerator, denominator. 3 times 1, 6 times 4. 3 and 24 are both divisible by 3. So you're going to divide the top and the bottom by 3 to get 1/8. So that is the simplified answer of this problem. I do want to point something out before we move on. This might help you. If you can't see it or don't like it, then you don't have to do it this way. You'll notice that I have a 3 and a 6. 3 in the numerator, 6 in the denominator. You can reduce before you multiply if you want. So let's just look at that. If I were to reduce it, 3 and 6 are both divisible by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So now we have 1 times 1, move that up, 4 times 2 to get that 1/8. Isn't that so neat? So you can reduce first if you want to, but if you don't want to, you can do it the first way I did it. Let's look here. 7 times 2, 8 times 5. You might notice we have a 2 on the top in the numerator and 8 in the denominator. So yes, we can reduce first if you would like to. 2 divided by 2 is 1. 8 divided by 2 is 4. So now we're dealing with 7 times 1 and 4 times 5. Move that up. Sorry about that. And we get 7/20. If that confuses you, you can keep it as is, reduce later. So 14 over 40, you end up with some bigger numbers, not huge, but bigger numbers. We know that these are both divisible by 2, and we get 7/20. 20th? It's hard to say. But you can see in either method, you get the same answer, so it really doesn't matter which one you choose. Last one. 10 times 2, 16 times 4. There's actually several numbers we can reduce here. They're all even. So we can reduce all of them by something, by 2 at least. Or you can just multiply straight across if you prefer. We get 64 on the bottom. I did that in my head, but if you're doing it without a calculator, you can do it this way. That's where I got that. and then reduce by 4. I think 4 is the largest. We'll just try it. Yeah, that looks right. So that is how you do it without reducing first. If you had chosen to reduce first, then you could reduce, these by 2 and these by 2. And that's where you get the 5/16. That's so neat. That's one of the things I love about math is that you don't have to do it one way. You can do whatever way that you're comfortable with it, and it should come out the same. As long as it's mathematically sound, then it should come out the same. Okay, dividing fractions. Let me do some backstory here. I put the dividing fractions in with multiplying fractions because division is technically multiplication of fractions. So I just say multiplying fractions because multiplying fractions encompasses dividing. Same with when we get into adding. Adding encompasses subtraction because subtraction is actually just addition of integers. So we really only have 2 operations, addition and multiplication. So that's why this is just called multiplying fractions, because that includes division. So there's your background. But let me show you this way. Division has one more step. If you do see a division sign, it has one more step than multiplying fractions, but it's really not difficult. So before I tell you what the step is, which you might already know because you might have heard a little memory verse or whatever, but let me just show you why. Well, actually, I'll tell you. So the memory verse is dividing fractions is easy. Don't ask why. Flip the second and multiply. And it's cute, but I really hate that saying because it says don't ask why. And I'm going to tell you that you should always ask why. If you are wondering, you should ask. Don't ever hesitate. If I don't know the answer, I will find someone who does. But in this case, I do know why. So it says dividing fractions is easy. Don't ask why. Yes, you can. Flip the second and multiply. And I don't want you to memorize that. I want you to know why it works the way it does. So I have this example here. It's 1/2 divided by 3/4. Now it looks a little weird because it's like a fraction within a fraction. But what happens here is my goal is to clear this fraction. I want it to be out of the bottom because it's kind of confusing down there. So if I multiply by its reciprocal, a reciprocal means that you flip the fraction. So I'm going to multiply by its reciprocal, but what I do on the bottom, I must also do on the top to keep it balanced. And when we multiply fractions, we know that we multiply the tops and the bottoms, numerators, denominators, and 12/12 is just 1. And then I'm actually going to extend this line. Multiply in the numerator, the numerators of the numerator, 1 times 4, 2 times 3. And what we end up with is 4/6 over 1. But anything over 1, we can kind of just ignore it because it's a 1. And anything divided by 1 is just itself. And we can just write it like that. So you can kind of see where when you divide fractions, you flip the second. Show you. Flip the second and multiply. Isn't that so neat? So yes, ask why. Okay, and we can write that down here, summarize that, and say when we divide fractions, we flip the second and multiply. Let's do a few practice problems. We have 3/4 divided by 1/8. Now this symbol, division symbol, is perfectly fine. On the previous page, it would have been written like that. So you might see it either way. You can use either way. It doesn't bother me. I'm okay with the division symbol. It's widely used. We know that we need to flip the second and multiply. So the minute you see this symbol, you know that you need to flip the second fraction. And then we multiply across. Ooh, what's 24 divided by 4? 6. That turned out nicely. I love that. Those are my favorite, when they start out messy and they turn out really nice. It's kind of like cleaning your house. When your house is really dirty and you're like, oh, I really don't want to deal with this. But you just get right into it and you start dealing with it, and then suddenly the whole house is clean. You're like, wow, that was worth it. That was so cool. That's math. That is the reason why I started loving math. I love that feeling. Okay. We see a division sign, which means we need to flip the second fraction and multiply. We get 2/16, which reduces by 2, whoops, there we go, 1/8. Isn't that wonderful? Okay, I have some examples down here that I want you to try. So if you would pause the video, try them on your own, and then hit play. I don't know if y'all heard that, but my cats, I think there's cats under the house. Hopefully you didn't hear that. So pause, try them, hit play. Now I'm going to go through them quickly. We multiply straight across, reduce, should get 1/20 on this number 7. Number 8, ooh, that looks like fun. So I'm going to deal with the numerator first. So I'm going to multiply, actually, we already have the answer to that. We did it in the previous problem, so I could have just done that. Divided by 1/4. If you want to rewrite that, divided by 1/4, that's fine. What that means is we're going to flip the second and multiply. Should get 4/20, which reduces, oh, I have lots of room, by 4 to get 1/5. Now I'm going pretty fast because I'm assuming that you paused the video and tried it on your own first. So you should just be checking your answers at this point. Make sure 2 times 1, 5 times 8, reduce, divide by 1/4, flip it. Yes, that looks right. Just double checking myself. Ooh, number 9 looks fun. These are all fun. I love these. 2 divided by 1/4. So I can rewrite this as a fraction. That might make it a little bit easier. Remember I said earlier that anything over 1 is just itself. So you can convert a whole number to a fraction by putting it over 1. And I didn't really change it. It just looks different. Kind of like in the morning when you wake up, you don't have any makeup on, and then you put your makeup on, you're still you. You just look a little different. So now we're going to flip the second and multiply. We get 8/1, which is 8. That's so nice. Last one. Same thing, we can put that 3 as a fraction, and we get 3/3, which is 1. Okay, so I want to point something out here really quick. You guys just thought you were done. This 1/3 times 3, those are reciprocals. They're called inverses. And when you multiply inverses, I'm not going to test you over this, but this is something that you should know if you're going on to other classes or other content. When you multiply inverses, you end up with the identity, the multiplicative identity. So multiplicative, it's a long word, inverses are basically reciprocals. That means when you flip them, like you flip 1/3 and it's 3/1. If you flip 1/2, it's 2/1, so you just flip them. When you multiply inverses, you get the multiplicative identity, which is 1. That 1 looks funny. 1. And this is going to help us when we get into solving. So that's kind of why I wanted to mention it. But that is all for this lesson. I hope you enjoyed it. If you have any questions, please email me and I would be happy to help.